Okay, so again, just to review here, we've graphed the 3 points of this triangle. We found the midpoint of AC, the midpoint of BC. Okay, we connected the two. The statement is that DE is parallel to AB. We can prove that by showing the slopes are both -3. And now we're going to prove that DE is half of AB by using the Pythagorean theorem and distance formula. So I've got root 10 and root 40. We want to talk about like root 10. How do we know it's simplified? Do you have an idea?
Is it because you can't, there's nothing that's squareable or that's able to be put into a root that you can multiply by 10?
Yes. What are the two factors of 10?
There's 2 and 5.
So if I think of square root, no, I knew I might do that someday, and I just did it. That's like the first time I've done that. Yeah, I did it. That's not good.
He's drawing.
There's the wrong pen on there.
That was
right. Let's see what we got. Okay, I did it off. You can't tell which is which. There's six colors. So there's all blue. Not a disaster. It was more of a disaster on the final screen. Disaster. This is actually salvageable. That was okay. Okay, so we made it. Dodged that bullet. So square root of 10. Wait, some of you will be a teacher someday. You get to be an idiot in front of like 30 people. It's awesome. So square root of 10 breaks down as square root of 2. As you're saying, it's square root of 2 and square root of 5, and neither of those are square rootable. Is I think what you said, right? You're right. You can't take the square root of either. Neither of them are a perfect square, so you're done. Okay, that's how you know you're done. Another way to think about it is if you don't have any pairs. So 2 and 5, neither of them have a pair. That means it's done. But square root of 40 is not done. How does square root of 40 break down? 4 and 10. 4 and 10. And we already know 10 can't be broken down anymore. Like there's no perfect squares going to 10. But 4 is 2. Square root of 4 is 2. So this is equal to 2 root 10. So when I rewrite this AB length as 2 root 10, I clearly see that length DE, length DE, which is equal to root 10. So DE, which equals root 10, is equal to 1/2 of 2 root 10, which is equal to AB. So big long run-on sentence in math, but DE is equal to root 10, right? 1/2 of 2 root 10 is root 10, which is equal to AB. 2 root 10 is equal to AB, I should say. This statement isn't clear. Let's leave it like that. So just think of it like this. So root 10 equals 1/2 2 root 10, and 1/2 of 2 is 1. So I've got root 10 equals root 10. So that proves it. My statement right here. So there it is. The statement is that DE is equal to 1/2 of AB. So that's the midsegment theorem in all its glory. We'll eventually get to a spot they came up with. It's from the textbook where they said, this is a way you might use this theorem. So example 2. What are the 3 pairs of parallel segments? Everybody get this written down? Got it? So what are the 3 pairs of parallel segments in triangle DEF? I'm going to do the first one and see if you can do the next one. The next 2, I should say. So I would say RT is parallel to EF because RT connects the midpoints of the 2 sides DF and DE, and EF then would be the 3rd side. So that's one parallel statement there. Can you get the other 2 parallel statements? No. DF is parallel to RS, yeah. So we got RS parallel to DF, and then can you get the TS parallel to? What's TS parallel to? D. You can visually tell on these, the ones that are parallel. So you actually have 3 sets of parallel segments when you connect all the midpoints. So we're going to ask you to do that at some point. Here's a triangle on a graphing grid. Find every midpoint connect all the midpoints, and you create a triangle that has all of its side lengths half the length of the original one, and parallel to the third side. So those are the three parallel statements. Example 3, it says, in triangle QRS, let's look at triangle QRS. TU and B are midpoints. What are the lengths of TU, UB, and QR? Well, if TB is 30, then QR has to be, this is going the other direction. This is half of QR, so QR would have to be 60. So QR is 60, it's double the length of TB. And then for the other two segments they asked the length of, I'm going the other direction. TU is going to be half of this 40. Here's TU right here. Here's the 40 right here. So TU equals 20. And then, color here, UB is the other one. So UB is half of that 50. So UB equals 25. So Midsegment Theorem just says two things. It says that when you connect the midpoints, you create a segment that's parallel to the third side. You can visually tell what that side is. And also, it's half the length. Okay, so there's a relationship there. That's it. Quite straight. Here's their attempt at giving you a real-life example of where you might use this. See what you think of it. Suppose you're a geologist, and you want to determine the distance AB across a sinkhole, but you don't want to fall in the sinkhole. That would be bad. So choosing a point E, this is an example. This is an example of a bigger idea. It's called indirect measurement. We do this in trigonometry too. It's like, you know, I don't want to send Jesus up to climb up the tree and then drop a, you know, plumb line down or drop a, you know, measure it. Okay, well, I'll hold the bottom and I'll say climb up to the top, and but we can measure it indirectly by using trigonometry. You get an angle measurement and you figure out your distance away from the base, and you can be pretty accurate with trig. And then Jesus is at the scaled tree. This is an idea of indirect measurement. Indirect measurement, but it says choosing a point E outside the sinkhole, she finds the distances AE and BE. So she finds the distances AE and BE. So she can measure these without it falling into the sinkhole. So you got to be careful on the edge here, but she can measure this. She locates the midpoints C and D. Those are also outside of the sinkhole, so she's still safe. So,
I fell.
Geologist, you fall into it, you're going, this is awesome down here. There's so many cool rocks. So she locates the midpoint C and D of AE and BE and then measures CD. What is the distance across the sinkhole? So she's able to get these midpoints totally staying outside of the sinkhole, right? She can measure this distance very carefully, but she can measure it. It's 46 feet. And now she's going to use that measurement in the Midsegment Theorem to figure out how far across this sinkhole is.
You know, like,
I could do this some too, but
yeah, so you just attach the string to one side and then just
she need another person. Yeah, I guess so. She could attach it to something. So, yeah. You hear that, Grayson? She'd rather do math. So, take that. So AB,
What was the sentence after?
AB, I didn't hear that one. I have selected. That's another thing as a teacher. You have to select it. So AB equals what?
a number.
46 times 2.
46 times 2. You let me do that?
92.
Okay, 92.
I don't know how.
So that's, you know, this is from the text. This is their example for, you know, real life sort of example.
That's actually a good geologist.
Going into sinkholes.
All right, so